All right. So let me unfreeze this here. So like I said, I just wanted to kind of formally talk about congruence because it's a concept we've used, but I guess I've never really hit it officially, so I just want to do it right now just to have it. Okay. All right. So congruence. Congruence, right? Congruence. Oops, I had this. There we go. Okay. The way that our book defines the book that we haven't seen yet. The way our book that we haven't seen yet defines congruence is thus. Okay, so let me show you. Two objects, okay, are congruent, okay, if they can be mapped onto each other by a series of rigid transformations. Okay, this is the definition used by our book, and it's not a bad one. It's just right now we're kind of putting the cart before the horse because we haven't talked too much about transformations right now. But examples of rigid transformations are transformations that involve, like slides or translations, right? Flips or reflections, or turns or rotations, right? Those transformations don't change the size or shape of an object. Okay? So, congruent objects are the same size, the same shape, and important to some of the proofs that we've used, they have the same measures. Right? Same measures. So, for example, when we talk about a segment AB that is congruent to a segment CD. Remember when we were writing in this sense, and by the way, that's the symbol for congruence, right? It's the equal sign with the squiggly on top. Okay? This statement is relating figures or objects. Okay? Figures or objects, right? We're talking about the segment, the thing, okay? The thing. Like an actual thing, an actual segment, okay? They're congruent. That means they're the same size, same shape. But then right alongside that, we could then simultaneously state that AB equals CD. Remember, when you don't put the segment mark above it, that means the measure of AB equals the measure of CD. Of course, if you don't like having to remember when and when not to put the segment above it, you can just put the M in front too and just say measure of AB equals the measure of CD. And then that'll also signify you're talking about the measure. Okay? An equal sign is used to equate value, okay, numeric value. AB and CD are referring to a numeric value, the lengths of those two segments. Segment AB and segment CD, congruent to each other, those are referring to objects, okay, figures. And so then the properties of congruence that we want to at least remember, okay, properties of congruence, I'm just going to highlight three. Just like we have a property, the reflexive property of congruence, we have the reflexive property of, equations, right? We have the reflexive property of congruence too, which basically says something like this. Here's an example. Angle A is congruent to angle A. Okay, there's the reflexive property of congruence. Angle A is congruent to angle A. No surprise there. Okay. The symmetric property, okay, of congruence. And here I'll give another example. If segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Okay, so that symmetric property, you're just like flipping the order around, right? Just flipping that order around. And then the transitive property also is true for congruence. And I'll do it with angles here. If angle A is congruent to angle B, and angle B is congruent to angle C, then what? If angle A is congruent to angle B is congruent to angle C, then what? Yeah, go ahead, read. Then angle A must be congruent to angle C. Is that what you're going to say too there, Charlie? Yeah, good. Very good. Yes. Okay. Good job, guys. All right. One thing I will highlight here, symmetric property and transitive property, we can kind of see a reason for those. Reflexive property, maybe we're still like, why do we even need to say this? Of course something is equal to itself. Of course something is congruent to itself, right? And I think the reason why it seems so silly for us to say this is because we're so familiar with equality and congruence that, we just kind of assume this property to be true. But there are other relationships that appear in mathematics where their reflexive property does not apply. For example, is there a reflexive property for the greater than symbol? No, this is not true, okay? So while it might seem kind of trivial, it's not always true. The reflexive property doesn't hold for every relationship in mathematics. For example, greater than or less than, stuff like that. So, okay. That's that for congruence. Any questions on that? Yeah.
I still don't understand the difference between, why could you just put an equal sign?
Because it's the nature of what these things are relating. When you use congruence, you're relating physical objects. I know a segment doesn't really exist in reality, but the drawing of the segment, that physical object of the segment would be congruent, the same size, same shape as the other thing. The equal sign, you're saying these two values, the numbers, and in other words, the length and the length, they're the same value, same number. Okay? So it's a subtle difference, and you're right. Why is it really that important? But in geometry, we differentiate between the two things. So. Okay, let's play with some toys. Here we go, okay? Please don't poke yourself, though, all right? Okay, maybe I shouldn't call them toys. Maybe I should call them tools. Geometry tools. Okay? All right. This is not going to work. Let's see here. I did my pencil, right? All right, I'll just use my pen, I guess. Okay, this is probably not going to work either because it's too skinny, though. Maybe it will. Okay, so one other aspect of geometry that we are going to explore today, and that we're going to kind of continue to explore as we proceed. All right. Yes, we can use geometry software to do stuff, right? GeoGebra, right? We can use it, but we can also do this ourselves, right? And this probably represents some ancient mathematics that have been known probably since before history was recorded, before recorded history, right? Prehistory, I guess you'd say. But of course, we have it used in use now here for certain things. So, basic things we want to be able to do. For example, we want to copy a segment. All right, copy a segment. And we're not using rulers here. We're going to use just our compass and a straight edge. This is actually also a compass too. I can maybe show some people how to use this if they prefer to try it. It maybe works better, maybe doesn't. I don't know. But anyway, what's that? Oh, you don't have to get these out. That's okay. They can just use this. It's fine, yeah. Actually, if you give me a piece of patty paper, though, I'd appreciate it. So we're going to practice doing these constructions two different ways. Compass and straight edge, and then I'll also show you using a patty paper, okay? Whenever it comes to you doing constructions, you can use whatever tools you want here, okay? But you need to also be familiar with the steps for the compass and straight edge because at times there will be questions where they'll be hey, here's this step that a compass and straight edge is using. Like, what construction are you doing based on what you see there? So you need to be familiar with both of them, really, but you can use whichever one you want, okay? Well, actually, you need to just know this one, but if you want to use patty paper, you can. But this is what you need to be familiar with here, too. Okay, moving on. So how do we do something like copying a segment, right? Well, some of you might just say, well, Mr. Whitmire, all I got to do here is just take this little straight edge and measure. Let's see, 0 centimeters is about 5.3 millimeters or 5.3 centimeters. Yes, you could do that, but I need to see the markings, okay? So here's how we're going to do it using our compass and straight edge. Okay, here's how we're going to do this. And this is not going to work well. To copy a segment, the first thing you're going to do is start by drawing a point, okay, like so, and then drawing a ray from that point that's longer than your segment that you've got there, that you're trying to copy. Okay? So a point to start, and that point we're going to call M, since that's what we're trying to copy here. Okay, I can kind of put M wherever I want, and I'll draw a ray that's longer than Mn. Okay? And then what you're going to do is you're going to take your compass here, put your compass point on the M endpoint, and then open your compass up so that it is the length of Mn, like so. Okay, and then you're going to make a swipe with your compass. Okay, but mine is like super loose here, so it's not going to stay. I'll have to do it with, I just got to do it with this. That's what I'm going to have to do. Okay, so compass point on M, and then you're going to swipe to show that you've marked off N, just like that. And then without opening or closing your compass, put the point of your compass right back on point M here, and then do that same swipe along the ray. Okay, so again, don't open or close things. Put that same compass point down, and then swipe. Oh, I think that moved on me too. Awesome. Do it this way. Okay. Okay. And so where that swipe intersects here, you're going to put a point down, and you're going to call that N. Okay? And there we've copied the segment MN. All right? Now, I definitely need a pencil for this next one, so. Okay, questions on that process? That's how you copy a segment using your compass and straight edge. All right, let me show you how to do with the patty paper then. This is called patty paper. It's kind of like wax paper. It's what you find between hamburger patties. If you like buy them from like a deli or something like that, they'll put this between them. Okay, this is not from hamburgers, right? This is like before they put them in the patties and stuff. Anyway, there's a smoother side and a rougher side, if you feel it. Okay, it's helpful if you're having trouble writing. Try and write on the rougher side. The rougher side will write better on it. Okay, if you can't tell the difference, then don't worry about it. All right, so smooth side down, rough side up. Cover up M and N. Okay, and we're gonna just copy these points M and N like that. Okay, so again, just like trace over the points M and N. So when I move my paper away, you can see there they are. Then you're going to flip your paper over, so now the rough side is down. And move your 2 points to wherever you want them to be. So I don't know, put them right here. And then draw on the back of those 2 points. And they should transfer to your paper, like so. And then connect them using your straight edge. And we'll call it M and N. Okay? Like so. Now I know we flip the paper over, so technically point M should be here, point N should be here, but it's a segment, so you can just flip it around. It's not a big deal. Okay? So there's copying. Questions on any of that? Okay, next we're going to be bisecting a segment. Okay, so when we bisect a segment, that means we are finding the what? Midpoint. Okay, so compass first. This is going to be a mess. For me at least, because my stupid thing is way too loose. Yep. Okay, so to find the midpoint, what you're going to do is put your compass point on the end point here of segment AB. Okay, and you want to open your compass up more than halfway. How much more than halfway? Well, I don't really care. If you're this much more than halfway, if you want to go this much more than halfway, of course, the bigger you make your compass, the bigger your drawing is going to be. So you don't want to go too crazy, all right? So I'm going to go something like that, okay? And then with your compass point down on point A, you're going to make a big swipe. And I think I can hold it so that it doesn't move. Okay, big swipe, just like that. Okay, I know we're going into the other picture. That's going to bother some of you people that don't like to mix your food on your plate and stuff like that. It's going to be the same thing, okay? Without opening or closing your compass any, put your compass point on point B and then swipe. And you create like a little football. Okay? Create like a little football. These 2 points of intersection of your arc, you're going to line your straight edge up with those 2 points of intersection. Okay? Now at this point, if you draw a line connecting those 2 points of intersection, you're creating a perpendicular bisector. Right? Bisector because it's cutting AB into 2 equal parts, perpendicular because it's going to be right angled to AB. But we don't want a perpendicular bisector, we just want the midpoint. So instead of drawing the whole thing, I'm just going to mark on my segment where my straight edge crosses, and then I'm going to make that a bigger dot, and voila, we have found our midpoint. So there it is. If you want, you can kind of like erase back some of your markings if you don't want to like have all these markings everywhere. In fact, when you do these markings, you don't have to do the whole arc if you don't want to. You can just kind of like, swipe down in this area and this area, swipe up here. So that way, you're not drawing all over your paper. But there it is. Okay, in fact, I kind of want to erase this back just a little bit so that way I won't get confused there. Okay, now, that was for the compass. Questions on using the compass? Yeah.
I have an eraser.
An eraser? Yes. In my drawer right there, Dalton.
Oh.
And then the yellow one. Oh, okay. They've got one. So, well, if you want to hold it, just hold it out just in case or something like that. So, thank you, though. Okay. Now, let me show you how to do this with patty paper. With patty paper, we're going to, again, trace our segment. So, you can kind of save space here. So, I'm going to just kind of start right here near my other information I had. So, I'm going to draw A and B. And I'm actually going to draw the segment itself, too. Okay, so actually connect those A and B's together using your straight edge. Okay. Now, I've got A and B drawn on my patty paper, and you guys are taking care of that right now. Okay. How do you think we can go about using our patty paper to find the midpoint of this segment? What do you think we could do? Fold it in half, exactly right. Fold it in half, okay? So we're going to fold point A onto point B.
Should the rough side be on the other side or this is?
It doesn't, whichever way you drew it is fine. I just suggest you draw on the rough side so that way, but however you fold it is going to be fine. Now again, you don't need to fold the whole paper, just fold right along where your segment is. See, I'm just going to fold right down here where my segment is. You don't need to fold the whole thing. If you want, you can. But I'm just going to fold right here along my segment, open it back up, and where that crease is, there's your midpoint. So I'm going to draw my point there. Okay, so there's my midpoint. But of course, I don't want the midpoint on my patty paper. I want to transfer it to my segment. How do I do that? Flip the patty paper over, line up your endpoints, and look at that. The midpoint lines back up to what we had from our compass construction, right? You can see they line up. Okay, and you can transfer the point over, obviously, if you're, if you use the patty paper instead, it transfers over to right there. Okay, same point, midpoint. Questions? Another compass? So I'm gonna, let me see here. Let me see what else. Well, I'll just try it. So this is a similar, I don't have any more metal compasses, like they're done. But if you want to try using this, what you can do is like, this is like the compass point, so you just like line that circle up on a point that you're looking for, and then this is like how you adjust it. Instead of like opening and swinging and opening and close, you just adjust this, and then you got that point.
Wow, it's only 150.
That kind of makes some sense. I'll try and show you while I'm showing that too, okay? Simultaneously. I'll grab one here. Okay. Let's copy an angle now. So, to copy an angle, remember, we want to go back to how we maybe started copying a segment. When we copied a segment, we started with a point already drawn and a ray. We're going to do the same thing for our angle. We're going to start not doing any measurements over here. We're just going to start by drawing a ray and then also having a starting point, like so. Okay? So a ray and a starting point. Okay? So this point right here is going to be the vertex for our copy, right? It's kind of like mimicking this side right here in a way. Okay? So far, so good? You don't even need to do 2 points. Just 1 point for your starting point, and then just draw the ray out from that. That should be fun. Okay, now, next thing we're going to do, take your compass point on the vertex of your angle that you're copying. Okay, like so. And what we're going to do now is we're going to swipe our compass so that it hits both sides of your angle. Okay, you may, when you do this, so I'm going to put my compass point here. You may, if you want, you can turn your paper. And this is already going to be a mess. Let's see, do this. You may want to actually turn your paper too to kind of help you. That can help if you want to just move your paper and kind of keep your compass stationary. See how I'm kind of moving my paper, and voila, we create that little arc there. Okay, that very same arc we're going to produce over here. Make it nice and big like the other one was, okay? I'm running into stuff. Okay, so make it nice and big like that other one was. Okay? Joey, for you, are you doing okay with it, you think? No. All right, so you're going to take your compass, center your compass on the vertex like that, so you can center the little point there. See what I'm saying? And then just adjust your little slider here, and then hold your finger down on a little circle, and then just kind of gently trace like that, and it should kind of work. It shouldn't slide, hopefully. Is it sliding? No, it works. Oh, it works. Good. I was no, it. Oh, yeah. Okay, never mind. I got it now. All right. So anyway, there it is. Okay. Now, this arc that we made created 2 points. We created a point right here where that arc intersected this side, and we created another point right here where the arc intersected the other side. We've got this point right here. Right? This point and this point are the same, but we need to find this point. One more time, get your compasses out. Measure from this point to this point. So open your compass so that it measures precisely to that other point. You see how it's there, right there, measured like that? Okay. Show that you've measured it by swiping. Ooh, it's going to move. Come on now, pencil, you can do it. Yeah, there you go. Oh, it's moving on me again. Oh my gosh. And the pencil's sliding out too. Okay, this is the suckiest compass. Okay, So anyway, there we go. Okay, again, I've done that swipe. So once you have that measured off and you've marked it to show that you've measured it, now you're going to pick up your compass and do the exact same measure and mark over here. Point down where it was and then make that swipe. And so now the X marks the spot there. And you're going to draw from your vertex through that little crisscross. Okay, and voila, we've copied the angle. Okay, so there's how you copy an angle. Again, this is something you need to be familiar with the compass and protractor, compass and straight edge, I mean. But you can always use our patty paper. It's pretty straightforward. All you do is you just draw your vertex. I'm going to draw both, just basically copy the angle onto your patty paper using a straight edge. Okay, all you got to do is just copy your angle onto your patty paper using your straight edge. Okay, so there I've copied the angle. And you're going to do the same thing we did before when we copied. Flip it over, and I'll just like reorient it somewhat there so we have like the same kind of thing. And then you can just like trace back the point, and I don't know, you can like trace, I don't know if it might work if I just like trace back on the arrows or something like that. It might just work. Yeah, there were the arrows, and then there's the point. So I can again just straight edge it. Okay, so there's another copy using the patty paper. And again, when I did that, I just traced over the, I traced on the back of the arrows and back on the vertex there, so it created that. Okay. There's another option. Last thing we're trying to do here, last thing, angle bisector. So far so good. Any questions on anything? Last one. Okay, here we go. Angle bisector. We have an angle, we want to bisect it. So we already should have an idea about what an angle bisector looks like, right? It's going to be a ray that goes from the vertex through the center of the interior of this angle, so something like this. So to do that, compasses. Don't throw your pencil out of your compass, though. Okay, well, this is getting worse before it gets better here, so let me go sharpen one more time. Okay, this is very exciting. Okay, try this one more time here. Hopefully things don't move on me. Okay, compass point on the vertex. You'll notice that's a familiar kind of situation here, right? Didn't we start on the vertex there too with our compass? So, compass point on the vertex, and guess what? We're also going to swipe so that we hit both sides of our angle. Ugh. Okay, so swipe to hit both sides of your angle there. And again, that creates those 2 points we saw before. Okay. And we're not going to measure that distance. I mean, you can if you want to, but it's not necessary to do that. All we want to do now, oh my goodness. All we want to do now is put your compass point on that new point that you created and swipe into the interior of your angle. Okay, and then without opening or closing your compass, put the compass point on the other new point you created, swipe into the interior of your angle. So they crisscross. So again, compass point on this new point here. Okay, and swipe into the interior of your angle. And then don't open or close your compass, swipe into the interior again, and they should intersect. Okay, and then straight edge from the vertex through the X. And there's your angle bisector. Okay, I didn't do a very good job because my compass sucks. So there's why I didn't do a very good job there. That's why it has a lid. Okay, so there's the angle bisector using your compass and straight edge. Here it is with patty paper. So with patty paper, we're again going to copy our angle, just like we did before. So just like completely trace the angle. Okay, completely trace. So vertex to arrows there. Vertex to arrows there. Okay. And so there I've copied the angle, traced it I should say. Any ideas? How should we use our patty paper now to find the angle bisector? Fold it again. That's right. Fold the side onto the other side and make sure your fold goes through the vertex. So make sure these two sides overlap and make sure your fold goes through your vertex. The crease needs to go through the vertex. Okay, each crease needs to go through your vertex. Okay, and then when you open it back up, the fold line is the angle bisector. So let's see how bad Mr. Widmeyer did. Poorly he did with his compass. Yeah, pretty bad. Pretty bad. Okay. So what you can do now is use your straight edge. Actually, you don't even use your straight edge. Sorry. Just put a point on that angle bisector. So again, once you did the fold, put a point on that angle bisector, flip your paper over, and then line up the angles again. Okay? And then copy on the back of that point from your angle bisector. And then straight edge from your vertex through that copied point. And you create a better angle bisector than the one I did with my crappy compass. Okie dokie. Questions on any of that? So, the rest of the class time is yours. You may continue to practice constructions if you want to, or if you want to get into some review for tomorrow's test, I posted an assignment on Google Classroom, okay? Whichever one you feel that you need more practice with, okay? There is no homework except to study for tomorrow's test, and that's what the review is for. I will go over the review tomorrow in class, so whatever you decide to do from that review, you'll see the answers for it. But we'll do it quickly because obviously I want to make sure we get started on the test and have enough time. Yes, I'm going to have Dalton come around and get those, but thank you.
Can I just throw this out or
Yep,
something?
you can throw that out, yep. So Dalton, if you don't mind going around and getting all the tools, well, get the tools from the people that are done with them, I guess. So if they're not done, then I would wait. But yeah, thanks for waiting too.
So, an example of making it congruent would be to like draw an angle like this right next to it.
You could, or you can do it separate. Like constructing an angle congruent to this one is the idea. It's just a copying it. It's copying.
I just wanted to be sure.
Okay, that works. All right, so get your Chromebooks out if you want to do the test review, or if you want to just do some more construction practice, do that too. Okay. Okay, yeah, go ahead. Goodness gracious. Yeah, I'll take that if you're not going to practice anymore. Yep, I'll take it. Okay. All right, well, if you don't want to look at that, that might be something you want to refer back to, but
Oh, yeah, you're right.
just in case so you know like what the markings are and stuff like that.
Yeah.
Of course, you can always watch the video too.